What's up everyone, welcome back. Patrick here, and moving on with infinite limits, we have to solve these three limits here. And notice that all three of the limits deal with the same function, this function 2x minus 3 over x plus 3. So the first way that I'm going to do this is the brute force way, so I'm going to do a table of values, because notice that all of these limits, they're approaching -3 because that's going to be the vertical asymptote. That's going to be the x value that makes the denominator 0 for this function. So if I draw out this function, or not draw out the function yet, but let's just draw out the vertical asymptote. So let's say this here is at that x value of -3. So the first limit is as x approaches -3 from the negative side. That's what that negative exponent means. So basically what's happening as we approach -3 from the left side. And then the second limit is as x approaches -3 from the positive side, or from the right side. And then we can figure out what's that general limit as x approaches -3. So basically as x approaches -3 from both sides. So for these two limits, what I'm going to do is make a table of values. So we got x, and then we have y. The y value is going to be given with this function. So let's pick a couple of x values that are close to -3 from the left side. So -3.1, let's say, -3.01, -3.001. So we would take these values, plug them in for the x values in this function. Just be careful with your brackets when you're plugging these in with your calculator. As x approaches -3 from the positive side, from the right side, so numbers close to -3 from the right side would be like -2.9 or -2.99 or -2.999. So we would take these, plug them into this function. Again, be careful with your brackets. So you're doing 2 times these numbers, -3, all of that in brackets, and then all of that in brackets. And when you input all these x values into your calculator, you'd end up getting these respective y values. So you could see the pattern. So as we approach -3 from the left side, notice all the y values are going towards positive infinity. So they're going higher and higher on the positive side. And then as we approach -3 from the right side, all the y values are going towards -infinity. So that way. And so those are the two respective answers for these two one-sided limits. So this limit here, it's equal to positive infinity, right? And then this limit here is equal to negative infinity, this way. So then what's this limit here going to be as x approaches -3 in general? Well, here we have to look at it from both sides, not just from one side, like these one-sided limits, but from both sides. So notice that as we approach -3 from both sides, the y values are approaching different values. So this one's approaching positive infinity, this one negative infinity. They're not approaching that same sign. And so this limit here does not exist. Right? So these two limits do, the one-sided limits, but this one doesn't. Now, if this function ended up being something like this, where from both sides it's going towards -infinity, or from both sides it's going towards positive infinity, then the limit would exist, and it would be whichever respective infinity sign that would be. But because it's going to opposite signs, it doesn't exist. And then the other way you can do this is, if you remember, this is a linear over a linear function. So from advanced functions, when you're graphing rational functions, we have that vertical asymptote here at -3. There's a horizontal asymptote at 2, which is the ratio of the leading coefficients. And then you can find out what is the y-intercept by plugging in 0 for x. So if we plug in 0 for x, we'd have -3 over +3, which is -1, which is like down here. And then if you want to find the x-intercept, it would be when the numerator is equal to 0. So if you make that equal to 0 and you solve for x, you'd get 1.5, which is like over here. And then just from these 2 points and the way the asymptotes are positioned, even if you didn't have these, you know that a linear over a linear function always has to look like this. And then you'd be able to tell what those limits are as we approach -3 from both sides. But if the functions are more complex, then usually you're going to have to make a table of values like that.